Alright, in this example, what we're going to do is we're going to start with the function square root of 2x plus 1, and we're going to find the slope of the tangent line to our graph when x equals 4. So I think we've seen how to find tangent lines, slopes of tangent lines. We need to compute the derivative, so that's what we'll do. So we'll have the limit as h approaches 0. And we take f of x plus h, which in this case, if we replace our x with x plus h, well, there it is. We just have 2 times the quantity x plus h plus 1. And then we do minus our function f of x, which is the original function, square root of 2x plus 1. That's all over h. What we're going to do next is just simplify. I'm going to go ahead and just distribute out underneath the radical. So we would get 2x plus 2h plus 1 minus the square root of 2x plus 1 all over h. And what I'm going to do now, I think we've seen some limit problems like this where we have radicals. A lot of times the trick is going to be to multiply by the conjugate, and that's exactly what we're going to do here. So we basically leave everything underneath the square roots just like it was. So the square root of 2x plus 2h plus 1. We change our minus sign to a plus sign, and then we multiply, again, just by the square root of 2x plus 1. Well, since we multiplied the numerator, we also have to multiply the denominator by the same thing. And I'm going to go ahead and stick parentheses around some of the stuff in the numerator just to remind myself to distribute here. So we'll have the limit as h approaches 0. Well, the square root of 2x plus h plus 1 times the square root of 2x plus h plus 1, that's just going to give us the quantity 2x plus 2h plus 1. When we multiply the stuff on the outside, the square root of 2x plus 2h plus 1 times the square root of 2x plus 1, we'll get something. We'll get the positive of that. But notice when we multiply on the inside, we get the exact same thing, but we're going to get a negative. So those just cancel out. And then we have a negative times a positive, which is a negative. The square root of 2x plus 1 times the square root of 2x plus 1 is going to give us just 2x plus 1. Again, be careful to put this in parentheses because we're going to have to distribute the negative out. And in the denominator, I'm not going to multiply anything out. I'm just going to kind of stick it all down there together. And again, I usually don't multiply this stuff out because, I think hopefully as you've seen from a few examples, at some point we'll be able to factor an h out of the numerator, cancel this out, and then we'll be able to actually evaluate the limit. Well, in the numerator we would have 2x minus 2x, so those would cancel. We would also have a positive 1 minus 1, so that would be gone. So we would be left with a 2h in the numerator. We still have our h in the denominator along with all the square root stuff. So 2x plus 2h plus 1 plus the square root of 2x plus 1. Well, now we can just cancel out the h's. And the last thing I'm going to do to get the derivative is just plug in h equals 0. So we'll be left with 2 on top. If we plug 0 underneath our in for h, notice our 2h term is just going to go away. We'll just get 2 times 0 when we do that. So we'll be left with the square root of 2x plus 1 plus the square root of 2x plus 1. Well, that says we have 2 of those, so we would have 2 times the square root of 2x plus 1. Last but not least, we can again just cancel out the 2's in this case. So our derivative, what we'll be left with now is just going to be 1 over the square root of 2x plus 1. And the last thing we have to do here right, we just wanted to find the slope of the tangent line when x equals 4. Well, now we've got our derivative formula. All we have to do is just plug in 4. So it says, hey, if we plug 4 in, we'll get 1 over the square root of 2 times 4 plus 1. Well, 2 times 4 is 8, plus 1 is 9, so we get 1 over the square root of 9, which is going to be 1/3, and now we're finished. It says the slope of the tangent line at that original point of x equals 4 we'll get the value, we'll get the slope to equal positive 1/3.